Problem 1. Approximate the sum, infinite sum, to the nearest 1/1000th. Example problem is sigma n equals 1 to infinity, -1 to the n plus 1 times 1 over n cubed. What you're going to do is set 1 over n cubed less than or equal to 1/1000th. Flip the sign, you get n cubed is greater than 1000, or n is greater than the cube root of 1000, or 10. So then what you're going to want to do is let L be the sum of the series, and absolute value of S sub 9 minus L is less than A10, which is equal to 1/1000. We can compute S sub 9, which then is within 1/1000th of our total sum. Problem 2. Find the nth degree of the Taylor polynomial. Part A is that. Part B, use Taylor to approximate the function and use the polynomial to calculate it. And part C is find the error bound. Okay. So this example is find the nth Taylor polynomial of y equals ln x at x equals 1 using p sub 6x to approximate the value of ln 1.5 and using p sub 6x to approximate the value of natural log 2. So first you're going to want to set it up. P sub nx equals k equals 0 sigma to n f to the kc, and fk is f prime, double prime, triple prime, fkc over k factorial times x minus c to the k. And for this one, it's going to be k equals 1 to n, 1 over k, x minus 1 to the k. So if you're computing p sub 6x, it would be x minus 1 minus 1/2 x minus 1 squared plus 1/3 x minus 1 to the cubed minus 1/4 x minus 1 to the fourth plus 1/5 x minus 1/5 minus 1/6 x minus 1 to the sixth. And blah 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 blah. We can approximate ln 2 with p6 of 2. So you plug in 2, 2 minus 1, minus 1/2, 2 minus 1 squared, plus 1/3, 2 minus 1 cubed, so on to give 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6. And that gives you a value of 37/60. To find the error bound, we need to, here's an example. Find the error bounds when approximating natural log 1.5 and natural log 2 with p sub 6x, the Taylor polynomial of degree 6 of f of x equals ln x at x equals 1, as calculated in example 2. So what you want to do is set absolute value r sub 6 of 1.5 and absolute value less than or equal to max of absolute value f to the 7th derivative of z all over 7 factorial times the absolute value of 1.5 minus 1 to the 7th. And that gives you 1506 over 5040 times 1 over 2 to the 7th, or 0.0023. Probably will be a lot more convenient on this test. Okay, so then problem number 3. It's an infinite series, and what we want to do is find the radius and interval of convergence. To find the radius and interval of convergence, you are going to take the absolute value of a function if it's an alternating series, and what you're going to do is do the ratio test. And once you have the ratio test, you figure out where it will converge, where x is, and that is your radius. And interval, if it's infinity, it will just be negative infinity to infinity. If it's 1, you have to go ahead and plug in 1 back into the original. 1 and -1, that is. It's problem 4. Find the power series of a given function f of x or Maclaurin using a geometric series. One example that we have here is going to be let's see here. 1 over 1 plus x cubed. You can rewrite that as 1 over 1 minus negative x cubed. Then write that as n equals 0, infinity, negative x cubed to the n, provided negative x cubed is less than 1. And then you can rewrite that again as n equals 0 to infinity, negative 1 to the n, x to the 3n. And that is your power series. Another one, 2x squared over 1 plus x cubed. So you can rewrite that as 2x squared, 1 over 1 plus x cubed. Bring out the 2x squared in front of n equals 0 to infinity, negative 1 to the n, x 3n. And rewrite that one more time as 2 times negative 1 to the n times x to the 3n plus 2. X over 5 minus x, you can rewrite as 1/5 times 1 over 1 minus x over 5. Bring out the 1/5 times n equals 0 to infinity, x over 5 to the n, and that will give you your x to the n over 5 to the n plus 1. And our last one here is 1 over 1 minus x quantity squared, and what you're going to have to do is take the derivative of 1 over 1 minus x. That gives you the formula of sigma n equals 0 to infinity x to the n, or nx to the n minus 1, from n equals 1. Alright, and one more. We have ln of 5 minus x. We can integrate that, and that is 1 over 5 minus x equals negative ln of 5 minus x. So what we want to set that up as is negative integral of n equals 0 to infinity x to the n over 5 to the n plus 1 dx, and our final answer for that one is going to be x to the n plus 1 over n plus 1 times 5n plus 1, 5 to the n plus 1. And for our final question, we are writing out the terms of a binomial series. For a binomial series, the Maclaurin is going to be 1 plus k times k minus 1 over 2 factorial plus k times k minus 1 times k minus 2 all over 3 factorial plus k times k minus 1 k minus n minus 1 all over n factorial, or a sub n equals k minus 1 k minus n minus 1 all over n factorial all times x to the n.